just wait a second because I see more people coming. Okay, folks, why don't we get started? So how many times do you say to yourself, the computer just doesn't understand me, right? Everybody who uses laptop, phone, desktop, tablet, doesn't matter. You're constantly saying the computer just doesn't understand me. How come I can't get this thing to do what I want? Even computer science professors who sort of nominally know how these things work and how to make them do things feel the same way as you, I promise you, okay, if not worse. Many of the problems that arise from people using computers are because, in fact, computers don't understand people. Okay? And to explore that, and to explore how we might make it better and what that might mean for the future, we need to start by understanding something about how humans communicate and what that might mean for how they might communicate with computers. So it's kind of a long story. It's long because biological evolution is very, very, very slow. The Earth has been around for about 4.5 billion years, and the first life appeared on Earth about 4 billion years ago, and over the course of those 4 billion years, life very gradually evolved the ability to communicate. Okay? So for about the first 2.5 billion years of life on Earth, life meant single-celled microorganisms like bacteria. Okay? Simple organisms like bacteria communicate very, very simple messages, like by changing the concentration of some chemical in their surroundings, or by exchanging small snippets of genetic material called plasmids, which is actually an important part of biological evolution. And for the first about 3 billion years or so of life on Earth, this was all there was for communication. Very slow, very limited. Gradually, very gradually, more complicated organisms evolved, and as they evolved the ability to communicate more complicated messages, but still pretty simple states, right? Like, I would be an excellent mate, or danger, danger. Eventually, to make a very, very long story very, very short, human beings evolved. And human beings have evolved communication skills that are uniquely powerful so far as we know. Humans use language to communicate ideas, right? I say something and you get an idea in your mind. It's amazing. Unlike animal communication, again, so far as we know, human language is based on these discrete symbols or concepts that are more than just the sounds that I'm saying or the words that are written down. The words of human language are in fact these rich, interconnected knowledge structures. I say or write the word dog, and you can't help but have an image of a dog appear in your head. Okay, maybe you're thinking what it looks like, how does it behave, does it bark a lot? Oh, I had a dog. All this stuff, right? It's amazing. Okay? Automatically and almost instantly, all this knowledge that you have about dogs is brought to your mind. It's amazing. English readers will have no problem recognizing these two words, okay? The senses of the words override even the shapes of the letters that they're written in. Here's another famous example. Experiments have shown that it's much harder to report the color that a word is drawn in if it's different than what the word is saying, okay? So in this example, it's much harder to say what color the word R-E-D is when it's written in yellow. You just want to say red. It's really hard not to say red. Turns out to be faster if they're the same, and if I ask you to read the word, it doesn't matter what color it's in. The symbols that underlie human language are even rich enough to discuss communication using a language whose concepts are rich, interconnected set of knowledge structures. That's what we're doing right now. So human language is fascinating. It took almost all of 4 billion years to evolve our language capability. It's a capability that is intimately connected to our knowledge and understanding of the world. Why would this language capability, why is this evolution of language important? Why did it happen? First of all, language is digital. Okay, so just like numbers are written with a fixed set of 10 digits, human language is based on a fixed set of symbols, or concepts, roughly speaking, words. Digital representations allow very, very accurate copying and transmission, okay? Almost error-free. Any old-timers in the crowd, you remember ripping a digital CD versus recording an LP or copying an audio cassette, right? You get a perfect copy of a digital CD, not so perfect copy of an LP or an audio cassette, at least when I did it, okay? So what does this mean? This means when some human back in history figured something out or figures out something now, they can pass it on to other humans very, very reliably. Okay? This accumulation of knowledge is what Daniel Dennett calls cultural evolution. And the thing about cultural evolution is it happens much, much faster than biological evolution. Okay? If you think things are changing faster now than they used to, you're totally right. Okay? Powered by language, ideas recombine and accumulate, and each new development becomes the building block for the next. This isn't just additive improvement, it's actually multiplicative. Okay? Through cultural evolution, human knowledge increases geometrically, so it's accelerating. One of the most recent products of our cultural evolution is the modern digital electronic computer. And computers are fundamentally digital symbol processors. Okay? They're the first non-human digital symbol processors as far as we know. They can transmit, recombine, and store symbols, and so you could say they understand a symbolic language. In fact, they do understand a symbolic language. The problem is, the symbols that they use in their language are much, much simpler than ours. The symbols of human language are these rich, interconnected knowledge structures, right? The symbols that computers understand are derived from the mathematical and electrical properties of how computers are built. They're essentially binary numbers, right? Made up of sequences of binary digits, bits, zeros and ones, off and on. Because computers only understand this really, really impoverished language, all we can do is tell them what to do, one tiny step at a time in terms of doing things to bits. Okay? We call this programming. All right? Not always quite as painful as this assembly language program over here, but even high-level programming languages, you're still telling the computer what to do, one very small, slightly larger than this, very small step at a time in terms of bits. I like to say that programming a computer is like trying to teach someone how to play the piano by telling them how to move their fingers, their hands and fingers, okay? Rather than talking about notes and scales and keys and melody and rhythm and all these concepts of music, right? It's possible, perhaps, to teach someone to play Twinkle Twinkle by telling them how to move their hands, but you know, it's not going to work out very well in the long run. Okay, so computers are these incredible symbol processors. They can compute many things faster and more accurately than humans, but while it's safe to say that they can do a lot of things, they don't understand anything that they're doing. Okay? And this has many, many implications. Okay, for starters, when something goes wrong, right? Boom. Okay? You've all seen one of these. Actually, I'm a Mac guy, so I would see this, all right? But either way, the program just stops, right? Sometimes the whole computer just stops, and you've got to plug it back in. You know, unplug it and plug it back in. It has no understanding of what it's doing, so when something goes wrong, there's nothing it can do about it, except just stop. Okay, well, long story short, these days you can talk to your computer, right? Siri, Alexa, Google, whatever. seems more like a person. Surely that's going to be better than this nasty programming stuff, right? Well, yeah. I mean, you definitely can get computers to do some amazingly useful things for you these days by speaking to them, okay? And I'll add, spoken interfaces are hugely important if you do a job where you're using your hands, okay? And we all do that when we're driving. But think also of something like a surgeon or a cook or a person working in a factory with their hands, okay? So this is all great stuff. But you know, it's not really communicating using language, okay? We're still only telling the computer what to do in tiny, tiny little steps. It has no idea what it's doing, so it makes lots of mistakes, okay? These mistakes that you can find under the heading of Siri fails or something like that, all right, they're kind of funny. I mean, they're trivial, first of all, and you know, they're generally kind of funny. People collect them and post them. But you know, if you were that surgeon trying to speak to the computer and get some information, it might not be so funny, right, if it made a mistake. To that point, we have so-called AI algorithms these days, right, that'll identify people and objects in pictures, but because they understand nothing about what they're doing, they label some people as gorillas, okay? They don't know what the words mean. For us, words are these rich, interconnected knowledge structures, and for them, it's just an arbitrary sequence of symbols that's attached to different outputs of the recognizer. Microsoft, a couple of years ago, deployed a Twitter bot. Okay, we were thinking of chatbots, okay? Deployed a Twitter bot. Used the latest in machine learning technology to learn from the conversations that it had with humans online. It didn't go well, okay? The thing was down within 24 hours. Of course it didn't go well. How can you have a conversation without some amount of understanding of what's going on, right? These days, simple computer models, right, trained on past examples, decide if someone gets a mortgage or if they get parole. Current machine learning methods, because they're based on examples from the past, can just be trained to relearn the biases of the past. Furthermore, these models can't explain the why of their answers, right? I think that ought to actually be unacceptable in society. So when I give a student a grade, like an A or an F, I need to be able to explain why. Not so much the A's. I don't get so many questions about that, okay? But I need to be able to explain why. I think if we're going to take away someone's freedom, someone's liberty, the least you could do is get a why, and the why ought not to be the computer said so. Okay, so bottom line, right, computers, whether it's AI, whether it's assistants, they really don't understand what they're doing, okay? There's only so much you can expect from a system that doesn't understand what it's doing. Those of you who are parents, or perhaps teachers, will know what I'm talking about, all right? Without understanding, in the form of these rich interconnected knowledge structures of human language and cognition, it's hard, I'm going to say practically impossible, to handle unexpected problems, okay? So you run into something that you haven't seen before, there's nothing to fall back on when your instructions fail. It's hard, I'm going to say barely possible, to learn new things. I mean, yeah, we can learn a little bit on the margins, which can be useful, and we call that learning these days, but it's not learning like humans do in the context of what fueled our cultural evolution, right? In fact, it's hard, and again I'm going to say barely possible, to even have a two-way conversation with a computer, rather than a kind of input-output. Hey computer, here's some input. Oh, thank you for the output, you know? Very hard, very, very hard. When humans work together, it's not a matter of one person simply giving commands to another. I mean, I hope not, from where you work, okay? Generally speaking, what do? Well, we have to get together and we have to agree on what to do. Sometimes someone's in charge, so they get to say what we're going to do, but even so, we have to agree to recognize their authority, we have to agree that we understood what we were told to do and that we're going to do it and all this stuff. If no one's in charge, it's a little more complicated, but we figure it out, right? And then we think about different ways we could get our jobs done, we think about various outcomes, and again, uniquely, so far as we know relative to other animals, humans will consider hypothetical scenarios. What if they do this? What should we do? You know, what would happen? What should happen next? Okay? We commit to some course of action, usually again very high level, like You look after that stuff, I'll look after this stuff. Right? And then we go off and we do it, but we're constantly checking back in. Are we making progress toward our goals? Are we stuck on something? If so, we need to loop back in and work together some more. This way of working together, which, again, so far as we know, is unique to humans, okay, encourages a bunch of things. It encourages agreement about what to do so we're not working at cross purposes. Okay? So an efficiency thing. It encourages autonomy. Okay? That's taking initiative to get the job done. Okay? So sometimes that's doing something, sometimes that's saying something. Right? Someone's got to speak up and answer the question. Might as well be you, if you know what you're saying. It encourages commitment. And commitment is another efficiency thing. It's how we work together efficiently. If I can trust that you're committed to doing that, I'm not going to worry about it. Because, first of all, you're going to work on it. And your commitment also means that you'll tell me if you're not going to get it done. So we may have to revise our plans, that's fine. But you're not just going to fail me. Okay? And ultimately, it leads to understanding. Right? Why? Because we can always ask why. So, we have these computers with immense computational abilities. They should be helping us, but instead we have this. Right? Either we can't get them to do what we want, or we settle for what we can get them to do, which is often turns out to not be really what we want, and even more likely to not be what we need. Okay? Computers could do so much more for us, or perhaps I should say with us. How do we get to that? So the human language that powers our cultural evolution is built on rich, interconnected knowledge structures. For computers to participate in that, we have to give them more knowledge and more language abilities that are based on and grounded in that knowledge. Okay? We have to give them knowledge about general things about the world as well as the specific problems that they're working on. We need to give them knowledge about when to communicate and how to communicate and what does it mean when someone says something. We have to give them knowledge about how to solve problems. Of course, that's what we want them to do. We even have to give them knowledge about knowledge, right? Which we call meta-knowledge. So, why do I believe this? Who told me? Where did it come from? Did I read it on Wikipedia? Is it still relevant to what I'm doing? Is it still true? Okay, a lot of knowledge about knowledge. A lot of knowledge, period. There's a whole laundry list, equivalent laundry list on the language side. I'm not going to talk about them except to emphasize the role of dialogue in working together, right? We work best when we work together. Humans are highly optimized for face-to-face spoken interaction. Of course, it doesn't have to be spoken these days. We can do it in email, we can do it in text, whatever, okay? But we're highly optimized for communication through dialogue, okay? Bottom line, working effectively together requires context. It requires that the computer understand what we're doing and why we're doing it. Okay, so that's a long list of things. Okay, and some of them are research problems, I get it. Let me give you an example though. When I was preparing this talk, right, I filled up my whiteboard with ideas of different things I wanted to say. And then I was going away for a week. So I said, I gotta take some pictures of the whiteboard, take it with me, right? So I go, I take 4 pictures, and then what? Oh my God, okay, open the Photos app, go to select mode, select the photos, tap share, wait for my laptop to appear, tap the laptop thing, okay, the photos go over, I gotta go over to the laptop, I gotta find where the photos ended up, I gotta drag them into the project folder for this talk. Okay, I'm old enough that I remember it used to be a lot worse, okay? But that's terrible, okay? That's horrible, what a pain. Imagine the following instead. Hey Siri, I'm gonna take 4 pictures of my whiteboard. When I'm done, I want you to put them in a folder on my laptop. Awesome, right? So I'm a scientist. I decided to try the experiment. It was interesting. If I said just the first sentence, I'm gonna take 4 pictures of my whiteboard. If I said just the first sentence, well, it showed me pictures of whiteboards, including the ones that I had just taken of my whiteboard just then. And I thought, well, that's pretty cool. Although I did think about it a little. I didn't tell it to show me pictures. I just told it I was going to do something. But it seems to know something about whiteboards. So I said, okay, benefit of the doubt, that's okay. Unfortunately, it did basically the same thing when I said, do not show me any pictures of whiteboards. Okay? There's also an interesting thing worth noting here. So this time, the words whiteboards came out as 2 words. Okay, and I thought I said it pretty much the same as the first time, but it came out as whiteboards. And the phrase whiteboards clearly doesn't match the category label that Apple uses to mark whiteboards in people's pictures. Even though for any speaker of English, we all know that a whiteboard, 1 word, is definitely a whiteboard, 2 words, right? So it probably doesn't know too much about whiteboards, after all. It went to the web, which is what Siri does if it can't find what you want, and there it uses the text surrounding the image to try to figure out if the image is relevant. And of course, there's zillions of pages where there's a whiteboard or a piece of wood painted white with the words white and board around them. So it has no problem finding those. But again, bottom line, it doesn't really know much about whiteboards, and it doesn't know really what I asked it to do. Okay, so just to conclude the experiment, I said both sentences, and basically it said, excuse me, maybe you're doing something with pictures. Okay? Which is all it got out of that. Those 2 sentences would be no problem, right? If I'm speaking with a human. No problem. And what's interesting, okay, I worked on this for a long time. Speech recognition is hard. Siri got all the words absolutely right. The only mistake it made was it got F-O-R pictures instead of F-O-U-R pictures, but that's not unreasonable. We have frames for pictures and boxes for pictures and stuff like that. So, and the 2 words sound identical, so this is a standard problem for understanding language. Okay? So even though it got almost all the words I said exactly right, it understood nothing of what I said. But what if we had a Siri with a bit more understanding of what's going on and a bit better language abilities, okay? How about something like this? So, hey Siri, I'm gonna take 4 pictures of my whiteboard. When I'm done, I want you to put them in a folder on my laptop. And Siri doesn't just sit there like a bump. It says, all right, you told me something. I'm kind of obligated to say something back, and I know it's your turn because you said you were gonna do something first, so I'll just say, go ahead. So I go, chick, 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 chick. Now, Siri knows that it's waiting for me to do something, and after that, it needs to do something. It knows that I just took 4 pictures. It's the same phone. There's no reason we can't know that. So it goes ahead and does its thing as soon as I'm finished, okay? And then it says something helpful, like I put the pictures in the folder named whiteboard on your laptop. And furthermore, it takes a little bit of initiative and says, you know, would you like to take some more pictures or add more pictures to the folder or whatever? Maybe because I've done that in the past, maybe because there's kind of a general principle that when you do something, sometimes you do it again. I don't know. Okay, it's a perfectly reasonable thing to do, and I just say no, but send the folder to Jeff. So it's a yes-no question. The answer is yes or no, but I added a but. There's always a but. That's the way humans work. It's very efficient. Okay? So off it goes, it does its thing, and then it comes back to me and says, Jeff's laptop isn't online, so I sent him an email. Why would they say that? Why would Siri say that? Well, perhaps I'm going to go over to Jeff's computer and we're going to start working on these pictures right away. I'm just warning you they're not there yet. They're in his email. Something like that. So I say thanks, and I'm just so happy that this job was basically done. All I did was take the pictures. Okay? People say this is impossible. It's not impossible. But it's not easy. I'll give you that. It's not easy. Some aspects of this are research problems, I get that. But honestly, software and system developers should already be doing a lot of what we need for this already, okay? User-centered design, it's been around since the 1980s when Don Norman's famous book, The Psychology of Everyday Things, was published. It's now called The Design of Everyday Things. I think psychology doesn't sell and design does. I don't know, it's the same book. The US government has a usability website where they talk about user-centered design, and they say things like it's based upon an explicit, meaning written down, understanding of users, tasks, and environments driven and refined by user-centered evaluation, okay, yada yada, you can read it yourself. Maybe you've heard of design thinking, very popular methodology for designing systems. Comes out of the Stanford Design School, the D School, and the people at IDEO who did a lot of the design for Apple in the early days. And they say design thinking has a human-centered core. It encourages organizations to focus on the people they're creating for, which leads to better products, services, and internal processes. When you sit down to create a solution for a business need, the first question should always be, what's the human need behind it? Okay? So the problem is, though, that many projects still don't follow these principles. They should. the design of these projects should be based on a model of the system and the user or users, or the systems and users, okay? But even then, if you do that design, we throw the design away when we write the code, okay? The code hopefully is inspired by the design, but all that knowledge that went into the design is not in the program. It should be in the program. It should be in the system. We should run the model. Okay, so it's not impossible, it's just not easy, and anyway, many things that were impossible just a couple of years ago are now commonplace. Okay? So I think that what we should do, though, is stop settling for computers that do what we can get them to do now, even if it's not what we really want or need, and we should get on with the job of building systems that actually do things that are important and that we need. Okay? Bottom line, we need to make human-computer interaction a lot more like human-human interaction. So there's a push these days to get more people able to write code, more programmers. That's teaching people to learn to speak the computer's language. I think we should be doing the exact opposite. We should be making more computers able to speak our language, so for the vast majority of people and the vast majority of problems, there's no programming involved. Okay? Programming's really hard, trust me. In the near term, right, the payoff for doing this is improved access to problem-solving tools for everybody. Okay? In the long term, there's kind of a fascinating possibility. Humans have always co-evolved with their technology, right? So as we have developed things, we have changed. Human-computer collaboration with the power of language will launch another evolutionary explosion, similar to what happened when humans first developed language amongst themselves. And this human-computer coevolution will be a really interesting symbiosis between our original tool for thinking, which is language, and our most recent tool for thinking, which is the computer. I don't think of this future as computers replacing people, okay? I see a future in which the power of computing is available to everyone, everywhere, all the time. That's the goal. Seminal computing pioneer Doug Engelbart described a vision of augmenting human intellect, bootstrapping what he described as an exponential increase in our collective IQ, us as a species understanding how the world works. And he wanted that in order to deal with the huge problems that were facing the world. And that was 50 years ago. That future, with humans and computers co-evolved in the future, will be different, that's for sure. But if we don't screw it up by misusing what we've already got now, I think we'll find that this cultural coevolution between humans and computers will make the rest of human history look like a slow motion movie. Okay? That's the power of language as far as I'm concerned. I'll take any questions. Thank you.